Assalamu alaikum. Good evening. Greetings, everyone. You're listening to Zoya Khan from Expert Trainers Academy. If you're new here, let me introduce you about us. Expert Trainers Academy is world-renowned provider of safety training and ISO certifications, and its services are available all around the globe. We are authorized to offer courses for organizations such as OTH United Kingdom, the European Safety Council, AOSH United Kingdom, Bharat Sevak Samaj, and India's Education Board of Vocational Training. We, Expert Trainers Academy, are committed in delivering the highest standard of health, safety, quality, and environmental training to develop a safer working environment.
Now, electrical safety. So without electricity, most of the things cannot be done these days. So electrical safety is another important aspect in the occupational wise. So an average of, one second, an average of one worker is electrocuted on the job every day. There are four main types of electrical injuries: electrocution, death due to electrical shock, burns, and fall from height. Like when you're carrying out some working at electrical work at height, and suppose you receive an electric shock due to imbalance, you fall from height, and that leads to injuries like bruises, etc. So this is falls. Electrical terminology: current, the movement of electrical charge in a circuit, measured in amperes. Resistance, an opposition to current flow, the flow of current, opposition, measured in ohms. Voltage, a measure of electrical force, measured in volts, symbol is V. Conductors, any substance or metals, most metals are good conductors of electricity that have very little resistance to electricity. Insulators, which have high resistance to electricity, flow of electrons. Substances such as wood, rubber, plastics, glass, etc. And then grounding, a conductive connection to the earth, which acts as a protective measure. Again, a question for everyone. Grounding, which control measure does it fall under? Whether it's fall under elimination or substitution, engineering control, administrative control. So please type your answer in the chat box. Moving on to the next slide. Electric shock received when current passes through the body. The severity, as I said, the outcome or the result of the severity of the electric shock depending upon many factors. One is the path that the current passing through the body, and then the amount of current that is flowing through the body, length of time or the duration of the time that the person is exposed to the current, and then the environmental condition that the person is receiving the electric shock, or the cloth condition, whether it is the cloth, if it is wet, so water is a good conductor of electricity, and salt water is a very good conductor of electricity. So if you're wearing any wet cloth or something like that, then the severity would be high. And suppose if you're standing on any metal, which are good conductors of electricity, and if you're standing on any water or wet condition, again it's a good conductor of electricity. So these are the factors that determines the severity of electric shock: the path, the amount of current that is passing through the body, and the duration a person exposed to electricity. So the low voltage does not mean low hazard. What are the dangers of electric shock? A current which is greater than 75 milliamperes can cause ventricular fibrillation, which is a rapid, ineffective odd beat. The odd beat function becomes irregular. So it will lead to death in a few minutes unless the defibrillator is used. 75 milliamperes is not much current. A small power drill uses 30 times as much. How is an electric shock received? When two wires have different potential differences. Potential difference, nothing but voltage. Current will flow if they are connected together. In most household wirings, the black wires are at 110 volts relative to ground. The white wires are at 0 volts because they are connected to ground. If you come in contact with the energized, the live black wire, and you're also in contact with the white grounded wire, the current will pass through your body and you will receive an electric shock. How is an electric shock received? If you're in contact with energized wire or any energized electric component and also with any grounded object, you will receive an electric shock. You can also receive an electric shock when you are in non-contact with the ground. If you contact both wires of 240 volts cable, you will receive an electric shock and possibly be electrocuted. Electric burns is a risk of an electric shock. Most common shock related non-fatal injury occurs when you touch electrical wire or equipment that is improperly used or maintained, or it is not properly insulated. Typically occurs on the end because you're going to be carrying the portable electrical equipment. If there is any insulation damage and you're operating it, you might receive an electric shock if you are come in contact with the live wire. So very serious injury that needs immediate attention. Falls, like I said, if you're carrying out certain electrical working at height, suppose you receive an electric shock, that would lead to imbalance and you might fall down, and that leads to a personal injury. It's called secondary injuries after falling from height. So inadequate wiring. Suppose the wire is too short, or you are not using the plug and you're putting the wire directly into the socket and you're operating the equipment that draws a lot of current. So that leads to overheating of the electrical equipment or overheating at the socket that leads to spark, which can cause even fire. Moving on to the next slide. Overloading, like suppose if you're using junction box. So junction box is using basically that you are connecting different equipments that draws power from it. When it draws power from it, the junction box gets heated and then it causes fire again. So if too many devices are plugged into a circuit, the current will heat the wires to very high temperature, which may cause a fire. If the wire insulation melts, arcing may also occur, and electrons jump from one place to another. That's called arcing. It usually involves high voltage and cause a fire in that area where the overload exists, even inside a wall. So what are the protective devices? Fuse, circuit breakers, ground fault circuit interrupters, and then RCDs, residential correct devices, double insulation, or lowering the voltage using a transformer. So these are the protective devices that you can use to reduce the risk of or eliminate the electrical hazard. Moving on to the next slide. See, how does the fuse function? So the fuse has certain ratings. When the current power exceeds that rating, what happens? It eats that circuit and then it melts. So and it breaks the circuit. So that's how the fuse works. Ground fault circuit interrupters. This device protects you from dangerous shock. The GFCI, ground fault circuit interrupter, detects the difference in current between the black and white circuit wires. This could happen when electrical equipment is not working correctly, causing current leakage. If a ground fault is detected, the GFCI can shut off electricity flow in as little as 1/40 of a second, protecting you from the dangerous shock. That means what? You will receive a minor electric shock, even an earthing. So you will receive it. It's all, to reduce the consequences of the electric shock. So the earthing and GFCI, so all these protective systems. Grounding hazard. Some of the most frequently violated OSHA standards. Metal parts of an electrical wiring system that we touch should be at 0 volts relative to ground. Housing of motors, appliances, or tools that are plugged into improperly grounded circuits may become energized. So if you come in contact with improperly grounded electric device, you will be shocked. See, generally, what are the electrical hazards we could see? Or see, we are using the wires, which there is no plug in it, but still we are putting into that socket and then using it. Or carrying the electrical tools, electrical appliances using the wire. So these are the other electrical hazards that we could see. Overhead power line hazards. So most people don't realize that the overhead power line cables are usually not insulated. Power line workers need special training and PPE, personal protective equipment, to work safely. So use the fiberglass ladder, which is non-conductive. Do not use any metal ladder. Even you can use wooden ladder, but that must not be in wet condition. Beware of power lines when you work with ladders and scaffolding. So make sure you keep a safe distance from the overhead power lines. Grounding path. The path to ground from circuits, equipment, and enclosure must be permanent and continuous. So that inspection must be carried out by a competent person. There is a violation shown here in this slide on the right side of your picture. An extension cord with a missing grounding prong. So these are the typical plugging system which are used in USA predominantly. So our plugging system are a bit entirely different, like in India. Handheld electrical tools. Handheld electric tools pose a potential danger because they make continuous good contact with the hand. So you're carrying portable tools that you're carrying from one place to another place to carry out certain work. So to protect you from shock, electrical burns, and electrocutions, the tools must have a 3-wire cord with ground and be plugged into grounded receptacle, or it must be double insulated, double insulation, double 2-layer of protection. Either of one of the layers will give sufficient protection. That's why it's called double insulation. Be lowered by a low voltage in isolation. So you can use a transformer to reduce the voltage from 220 volts to 110 volts. So when you reduce the voltage, so the severity will be reduced when you receive an electric shock. That's the whole purpose of using a transformer. The next slide. Guarding the live parts. So basically barricading. So it can be either approved cabinets or enclosures. It can be permanent partitions. So there must be elevation of 8 feet or more above the floor or working surface. Mark entrances to guarded location with conspicuous warning sign. So like in the picture, we could see it's mentioned danger, high voltage. So you can warn using signages. So what is this signage? Which control measure? Again, a question for everyone. The signages, the prohibition sign or warning sign. So which control measure does it fall under? Whether it is engineering control or administrative control. Guarding our live parts. It must be fully enclosed or guarded electrical equipments in location where it could be exposed to physical damage. See, in this picture, there's a violation here, which is a physical damage to the conduit. So which must not be. That might lead to an electrical risk. Cabinet boxes and fittings. The junction boxes which you use or the pull boxes which you use, the electrical fittings that you use, must have an approved covers. And unused openings in cabinets, boxes and fittings must be closed. So there's a photo which shows a violation of these 2 requirements, which is not protected at all. So use of flexible cords. More vulnerable than fixed wiring. Do not use if one of the recognized wiring methods can be used instead. Flexible guards can be damaged by aging, the number of days that you've been using. It can be, stuck into the window edges or door edges. It can be, fastening. It can cause abrasion from the adjacent material. It may lead to chemical abrasion or chemical damage. Chemical corrosion may occur on the insulation. So, or the other activities that is carried out in that area that could lead to cause the damage of the insulation, which leads to live electrical cable that you might come in contact with, that leads to electrical shock. So improper use of flexible guards can cause shock, burns, or fire. Prohibited uses of flexible guard examples. Substitute for fixed wiring, run through the walls. See, basically you attach them on the ceiling or the walls. What are the clues? How to identify the electrical hazards exist in your building or in the workplace? Frequent tripped circuit breakers or blown fuses. Tools become warm quickly. The wires become warm quickly. The cord or the cables or the connection, the junction boxes get overheated. GFCI, the ground fault circuit interrupter, shuts off a circuit very frequently. There's a worn or frayed insulation around wire or connection. So the insulation gets broken off from the wire or the connection. So these are the things that we can identify. Yes, there is electrical hazard exists in the building or in the workplace. Training. Train the employees who are working with electrical equipment in safe working practices, including de-energizing electrical equipment, use of lockout tagout system, using electrical tools that are in good condition, using good judgment when working near energized lines, using safe system of work and permit to work system when you're working on the overhead power line cables, using appropriate personal protective equipment. So the training must be provided to all workers who are involving in electrical works. The summary about this topic: hazards, inadequate wiring, exposed electrical parts like damaged insulation, wires with bad insulation, ungrounded electrical system appliances, overloaded circuits like overloaded junction boxes, damaged power tools and equipment. The inspection is not being carried out regularly on the electrical equipments and appliances, or the inspection being carried out by incompetent person. We fail to identify the electrical hazards or the overhead power line cables hazards. All hazards, especially the electrical hazards, are made worse in wet conditions. So what are the protective measures that we can use? We can use proper grounding. We can use GFCI. We can use RCD. We can use MCD, fuse, earthing, double insulation. And then all the electrical works like inspection, maintenance must be carried out by a competent person. So whenever you're working with any overhead or you're excavating certain grounds which has the electrical cables, so you must use safe system of work and permit to work before doing so. So these are the things that we can do to protect ourselves. So that's about it from this topic.